Okay, so now we'll move on to the next part of our lesson. So we are now going to learn how to work with probability formula. Okay, so they say there is a formula you can use for two events that links the probability of the union and the probability of the intersection. So let the probability of A be A. Now probability of capital A means the set A, right guys? Okay, is equal to A, and probability of capital B, the set B. Okay, so that's the set B is equal to simple B. Okay, so this is the probability of A intersection B is I. Now they have marked the probabilities of each and every region, right? You guys can understand what's going on here, right? So they are saying the probability of the first big circle is A. That's why so the probability of circle A, capital A is simple A, okay? And the probability of the set B, capital B is simple B. And they say the intersection. Now guys, you know the intersection is the probability in the middle, right? That is equal to I. All right, so that's equal to I. And you can see how they have marked over here A minus I, because the whole circle is A. From the probability A, you subtract this value, right, to get this. And this whole circle is B. You subtract from B this I to get this value over here. So you can see what they've done here. Basically, you are adding all the regions. Now A union B. Guys, you know when it comes to A union B, okay, look at the formula they have written here. They are saying probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Guys, what do you think about this? Is correct? Okay, now if I take A, let's check them out individually. I think you can, if you check on this, you can see it's definitely working out. But let's write separately. So A union B. What are the regions coming for A union B? You know, A union B means you take all the regions that belong to circle A, and also you take all the regions that belong to circle B, right? So union means you take everyone. It's a or, right? You take everyone, not the common thing. You take everyone. So what do you get here? I think you can see you get the region A minus I. Can you see? You get the region A minus I, and then you get the region I, and you get the region B minus I. Can you guys see? You get everyone, right? That's what you mean by union. So when you add everything, I think you can see minus I plus I cancels, and you get here A plus B minus I. Do you agree? Shall we check the other one as well? The other side. Now I just got the answer for the left side. Let's get the answer for the right side also. PA plus PB minus PA intersection B. Let's see if this works. So what's the probability of A, guys? Probability of A means the entire blue circle. So the entire blue circle A minus I plus I think you can see it's just A. Do you see the full blue color circle is A minus I plus I, it's just A. And then probability of the circle B, the green color circle. The green color circle is B minus I, and I B. Minus probability A intersection B, guys. So A intersection B is the probability that comes in the intersection of A and B. So what's the intersection of A and B? Intersection is the part that is coming in the middle here, right? Can you see? Intersection is the part that comes in the middle here. So that's I. And you can see, so over here I can't simplify anymore. So it's A plus B minus I. Can you see that both of them are equal to each other? So that's why we say probability A union B can also be found by adding the probability of the set A. You add the probability of set B and you subtract A intersection B. Okay, so write down. So this is one of the main equations, and we call this as the addition formula. All right, guys. So we call this as the addition formula. All right, guys. And then for the next section, I just quickly came back to what we did on the previous part. On a previous section, I think you recall we learned something about events being independent, right? So if you recall, when events are independent, if two events A and B are independent, it means the conditional probability. So probability of A given B. Basically, the probability of A happening given that B has already happened, you can see it doesn't depend on B, it's directly equal to probability of A, right? So probability of A happening doesn't depend on B. That's directly equal to probability A. And over here, probability of A given B complement. It means the probability of A happening given that B doesn't happen. That's also probability of A. Why? Because probability of A doesn't depend on whether B is happening or whether B is not happening. So it makes no effect on A at all. All right, guys. So this was something that we discussed previous, right? So now we are going to actually define another equation for conditional probability as well. Okay, so let's make that. All right, guys. So we'll come back to the independence, but before the independence, actually, what I wanted to show you is the kind of like the we did not define an equation for the conditional probability, but we did discuss. I mean, we did do a few exercises that did use conditional probability, right? So we'll come back to the independence condition afterwards. We have it in the next part, but for now, we are going to actually give you an equation for the conditional probability. So there were two exercises we did with respect to conditional probability, right? So probability of B given A. Now here it does not assume any independence or anything. So maybe the events are depending on each other. So over here, okay, so that's we're not taking a condition of independence. Okay, we are not taking such a condition here. So they are saying, for example, the probability of B given A. Now we've done so many questions with respect to this, right? So the probability of B given A. Okay, so the what's the probability of B given A? The probability of B happening given that A has already happened, right? The probability of event B happening given that A has already happened. So over here, so this is the event B. So you know the rule, right? So first of all, in the denominator, you write the probability of A because we take everything from the given that probability because it's the event A that is the one that has already happened. So from event A, the probability of event A is what you write in the denominator, right? Do you recall? So there were many questions which we did with this, right? And on top, what do you write? You write the probability of A, probability of B happening inside the set A. Do you recall? So we write the probability of B happening inside A. So this is the red color circle is A. The probability of B happening inside A is this green color part, right? Can you see? This green color section is the only part where B is happening inside of it. Do you agree with me? So that's why so we should write that probability on top here. So guys, you can see that that probability I, that is the intersection. So that is the B intersection A, right? Or you can even write A intersection B. Do you agree with me? So the probability B given A is probability B intersection A. That's the green color part over probability of A, right? So these are rules that we used earlier. Okay, so we've used these rules earlier, and you should definitely be. I mean, we did not use a rule earlier, but we did practice the principle, isn't it? We did practice this principle. We used them in Venn diagrams and we used them in the tables, right? So we were drawing those two-way tables and we calculated these probabilities, even though we never used the formula. Okay, so now we have a defined formula for this. So probability B given A is probability B intersection A over probability of A. And also you can write the formula for A given B. So if you have the formula for A given B, how does that work? So denominator should be what? The given that probability is what we take, right? So because we don't now we don't, when they give you a conditional probability, you don't have the entire Venn diagram. You only have the given information. So you take the probability from the given information. The given that part is B now. Can you see? So now the given that part is B. So if I take the Venn diagram, so this is the given that probability. So circle B, and now inside this circle B, what's the chance that A is happening? So inside this circle B, the chance that A is happening is this small part, right, guys? Can you see? So inside the event B, the probability that A happens is this small part, which is the intersection. Can you guys see? The probability is I. So that is the A intersection B, or you can even say B intersection A. They're both the same. Can you see, guys? And then what they've done here, for the next part of this is they've taken this to the other side, the probability B. Can you see? Probability A given B into probability of B. So guys, this is what they've done here. All right. So even over here, they've just taken the probability A to the other side. So probability B intersection A is equal to probability B given A times probability of A. All right, guys. So we'll come into the independence condition later. So there are more rules that we'll be working. But first, let's practice in using the addition rule, and also let's practice using the conditional probability rule. All right, guys. So now let's practice using those rules. Okay, so we'll practice the addition rule first. Okay, so they say here exercise 4G, A and B are two events where the probability of A is 0.4, probability of B is 0.5, probability of A union B is 0.6. Okay, so if you want, you can even draw a Venn diagram, but I think we are basically trying to, do this by using the rule they have given us, right? So anyway, if you draw a Venn diagram, I think you can see all these probabilities very easily, but we mainly want to try to use the equation. Okay, so anyway, let me just draw a quick sketch. Okay, so they say here, okay, so you have two events, A and B. And they say the probability of A is 0.4. Guys, when they say probability of A is 0.4, it means the entire circle A, right? It's the full circle. And when they say probability of B is 0.5, it's the full circle. Okay. And they say probability of A union B, guys. So let me, mark these letters. I mark my regions A, B, C, D. So anyway, A union B means, guys, it's not, union means you take everyone into account, right? A union B. So actually, a moment ago, so we learned the addition formula for A union B. Did you see? So we proved it also. So A union B is equal to probability A plus probability B minus probability A intersection B. So shall we practice using the formula? I think you can even do it by using regions. Okay. So we'll practice with the formula. Okay. So probability A union B is equal to probability A plus probability B minus probability A intersection B. Let's fill the values. Probability A union B is going to be 0.6. Probability A is given to us, it's 0.4. Plus probability B is 0.5 minus probability A intersection B is what we need to find. Can you see? In part A, they are asking us to find probability A intersection B. Okay, so let's make the subject 0.6 equals 0.4 plus 0.5 is 0.9 minus probability A intersection B. So I'll take the minus probability A intersection B over here equals 0.9 minus 0.6. So probability A intersection B equal 0.9 minus 0.6 is 0.3. All right, guys, can you see? So that's really quite simple. You could even do it by using the ABC. You can say, or in other, if you try to do it in the normal way, you can say A plus B plus C is, equal to the 0.6, right? Because when you add the regions A, B, C, that's when you get A union B, isn't it? Because A union B includes all regions in A and all the regions in B. So that's simple A, simple B, and simple C. That covers A union B. And you can and you can try with this as well. Okay, so I'm not going to go with that. So I think this is a much easier approach. And then part B, what about the probability of A dash? So when it comes to probability of A dash, guys, you should recall probability of A dash is what? So the complement of A. The complement of A is 1 minus the probability of A, right? The probability of A complement is 1 minus the probability of A because you want the area outside of it. That's the complement. So it's going to be 1 minus, what's the probability of A? 0.4. 1 minus 0.4 is 0.6. All right, guys. Okay, so that's done. And the next one, probability A union B dash. Probability A union B dash. Okay, so guys, this you can do this manually, or you can again even use the addition. You can use the addition formula, the formula. Okay, first, shall we write down everything that we found? We found, let's mark it on our diagram. We found the probability of A intersection B as 0.3, guys. Do you see? Shall we mark the other regions? I think you can see the region A, simple A, region simple A can easily be found, right? 0.4 minus 0.3, right? That's 0.1 here. Because if this is 0.3, from 0.4 you subtract 0.3 and you get the answer here. Similarly, region C, 0.5 minus 0.3, that's going to be 0.2. And what about region D? You know, in a Venn diagram, total probability must always add up to 1. So if the total probability is adding up to 1, how much do we have outside? The region A, B, C, D, all 4 probabilities adds up to 1. So 0.3 plus 0.2, that's 0.5, here 0.6. So if you have 0.6 in the regions A, B, C, how much comes to region D? 0.6, you have to subtract 1 minus 0.6, right? The addition of ABC, 1 minus 0.6 is 0.4. All right, guys, I hope there are no questions here, right? We've done so many questions using these strategies in the previous exercises, right? So guys, this is the technique that we used earlier. Do you recall? So when you wanted to get the A union B dash, first we wrote the regions corresponding to circle A. So circle A, we have the region simple A and simple B, right? And then B complement. B complement means all the regions outside of circle B. So inside circle B, we have the regions BC. Outside of circle B, we have the regions AD. And then it's a union, guys. So a union means you take everyone into account, right? Not just the common regions, but you take everyone. So you have A is there twice, so you write it once. Okay, when it comes to union, you take everyone. So A, B, and D. So basically, all you have to do is to add the probability of the region A, simple A, add the probability of the region simple B, and add the probability of region simple D. Simple as that. Okay, but I want to actually, go for that. This is a technique we used in the previous exercise. So I just want you to practice a little bit with the addition rule. Shall we also try this with the addition rule? So if you have A union B dash, how will the addition rule change? I mean, it's again the same formula, but now instead of B, you have B dash. So you can try writing like this. So the first element here is A. So probability A plus, guys, the other one is now not B, B dash. So you should write plus probability B dash. Can you see? Probability of A plus probability of B dash and then minus probability A intersection B dash. Guys, do you see what's going on here? So I just use this exact same rule, but instead of B now, you have B dash. So if you have B dash, all the B's are becoming a B dash. That's it. The same rule, but instead of B, we have B dash. So you can rewrite the exact same rule. Are you with me? So I wrote that exact same rule, but instead of B, I wrote B dash. So guys, if you see these probabilities, are they hard to find? Okay, so what's the probability of A? This is an alternative method. Okay, so we are going in the addition rule method. So what's the probability of A? That's 0.4. What's the probability of B dash? Guys, probability of B dash is 1 minus probability of B, isn't it? Probability of B dash is 1 minus probability of B. 1 minus probability of B is how much, guys? 0.5. Because probability B is half, 0.5. So 1 minus of that because we want to get B complement. All right. So if you do 1 minus, you get the B complement. Do you agree? And then what about the last part? Minus probability A intersection B dash. What about A intersection B dash, guys? I think you can see over here, we can immediately find A intersection B dash, right? A intersection B dash. A is region simple A and simple B. B dash, B complement is region A and D. I think you can see intersection means you take the common region. What's the common region? Common region is A. So you guys should be able to see this without drawing all of this, okay? So when they say A intersection B dash, it means the region that's common to both A and the B complement. So that's region simple A. Okay, so if you guys can, do fine immediately when you see this, if you can immediately see the region, that will be really helpful and saving you a lot of time. So if you can see that A intersection B dash is directly this region simple A, you're gonna save a lot of time. All right, guys. Okay, so these are some important things, and now you can get the answer. Okay, so this is the way to get the answer if you use the addition formula, or else you can always go with the previous technique is also correct. Okay, so it's gonna be 0.4, 1 minus 0.5 is 0.5 minus 0.1. End of the day, the answer is 0.8. All right, guys. All right, so A dash union B, so you can again use the previous rule. So I just want to get you practice with the multiplication, the addition rule. So the addition rule is gonna be probability A dash, so A dash union B. Okay, so now instead of A, use A dash plus probability of B minus probability A dash intersection B. All right, guys. So what's the probability of A dash? We already found 1 minus probability of A, that's 0.6. Probability of B is given to us in the question, it's 0.5. minus probability A dash intersection B. So guys, once again, if you can see this directly, that would be a lot easier. A dash intersection B. So A dash means the region outside of A. So outside of A, we have region CD, and the circle B, you have the regions BC. And what's the intersection? Intersection means the common region. So common region is region C. So A complement intersection B is region C, which is 0.2. So you get here when you subtract 0.7. Right, guys? Sorry, I'm sorry, 0.9. 0.9. Okay. All right. So guys, we'll move on to question number 4. They say there are two events, T and Q. Sorry, there are two events, T and Q, such that the probability of T is equal to probability of Q is equal to 3 times the probability of T intersection Q. And probability of T union Q is 0.75. All right, guys. So let me mark my region. Simple. A, B, C, and D. Okay. So they are saying us the probability union Q means, you know, all these three regions, A, B, C, all three of them together adds up to give you 0.75. Okay. So they are asking you to find the probability of T intersection Q. All right, guys. Before we move on to that section, we first need to make use of this information here. Can you see that they have equated three probabilities here? Probability of T is equal to probability of Q is equal to 3 times the probability of T intersection Q. So guys, what you need to do is just try to, you know, you need to get use of this information. So for example, let's take the probability of which guy. I think you can see the easiest person to use a letter here. For example, let's take the probability of, okay, you can say let the probability of P intersection Q be equal to simple X. Just take any letter that you have not used here. Okay, it doesn't matter what you use. If it is a X or Y, just it doesn't matter what it is. Just use the letter T intersection Q is X. So which means what? Which means probability of T equals to probability of Q is equal to 3 times the probability T intersection Q, right? That's what they give. So this is equal to 3 times the probability of T intersection Q is X. So 3 times X is 3X. Can you see, guys? Which means the probability T equal to probability Q equals to 3X. Can you guys see? And also we said the T intersection Q probability is X, which means you can mark in the middle as X here. Can you see? So I'm marking the T intersection Q probability as X. Okay, and then the probability of T is 3X. Guys, can you see? So on top, probability means you mark the whole circle, right? Probability means the whole circle. This is 3X. And then probability Q means this whole circle. That's also 3X. Can you see, guys? So you can now actually, you know, to get T intersection Q, we can even use the, I mean, we can try to use the addition formula, right? Because we need to get the value. So you can use the addition formula. What's the addition formula? Probability A union B. Now instead of A and B, use T and Q. Are you with me, guys? It's the same formula, but instead of A and B, use T and Q. So T union Q is equal to probability T plus probability Q minus probability T intersection Q. Are you with me, guys? So you can use this equation. T union Q, probability of T union Q is 0.75. All right. Equals probability of T. Can you see, guys? Probability T, probability Q, they are both equal to 3X. So you can mark them. Probability of T is 3X. Probability of Q is 3X minus probability T intersection Q. Guys, look at this. T intersection Q, we use it as simple X. Can you see? So now you can get the value of X. 0.75 equals 3X plus 3X. That's 6X. 6 minus 1 is 5X. And you can get the value of X. 0.75 divided by 5. So how much is that? 0.15. So X is 0.15. Can you see, guys? So what we answer now, actually, X is something that we use for T intersection Q. The question is to find the probability of T intersection Q. Yeah. So probability of T intersection Q is equal to X, which is 0.15. And this is your answer. Is this okay, guys? This is clear. I hope this is clear with everyone. All right, guys. So moving on to part B, the probability of T. So guys, what's the probability of T? Probability of T, probability of Q, they are both equal to 3x, right? So multiply 3 times the x probability is 0.15, which is 0.45. So that's the probability of T. Part C, the probability of Q dash. Probability of Q dash is 1 minus probability of Q. Is that correct? The probability of Q complement is 1 minus the probability of Q. So 1 minus probability of Q is 3x. Okay, probability of Q is 3x. So 1 minus 3x value is, I think you saw 3 times 0.15, that's 0.45. So 1 minus 0.45 is equal to how much? 0.55, right? All right, guys. So part D, probability of T dash intersection Q dash. So for this, we can, go with our traditional way. You can, you can try some creative way. That's also fine. So I'll go with the method that I taught you all. So probability T complement means the regions outside of circle T. Outside of circle T, we have CD. Right, guys? And then Q dash. Q dash means the region outside of circle Q. So inside circle Q, we have BC. Outside circle Q, we have A and D. And then intersection means the region that's common. So region D is common. So region D, what's the answer? Okay, so region D answer should be found. And you can see we have not found that yet. But I think I hope you understand that it's actually 1 minus all these three probabilities, right, guys? A, B, C. Because the inside probabilities are A plus B plus C. If you subtract from 1, these three probabilities, you should get the outside probabilities. Is that correct? So 1 minus, do you know the addition of ABC? Yeah, we know the addition of ABC because this addition ABC is the T union Q, isn't it, guys? Right? So T union Q is what you get when you add A plus B plus C, right? So 1 minus the probability T union Q. All right, guys? So 1 minus the 0.75 because 0.75 is what you get when you add these three regions. Subtract 0.75 with 1 and you get region D, which is 0.25. All right, guys? And last part, probability T intersection Q dash. So T intersection Q dash. What are the regions belonging to circle T? So circle T, inside you have AB. Q dash, Q complement. Outside of circle Q, you have A and D. And intersection means take the common region. What's common to both? I think region A is common. Can you see, guys? Region A is the answer. So what's the probability of region A? The whole circle is 3x. The intersection is x. So 3x minus x. Agreed? So 3x minus x is 2x, guys. And we know the x value. X is 0.15. So 2 times 0.15 is 0.3. All right, guys. So this is the answer. So these are the answers for these questions. All right, so next we'll move on to question number 9. So they say the probability of A is 0.42, probability of B is 0.37, probability of A intersection B is 0.12. Find the probability of A union B. So to do this, you don't even need the diagram because you know we can use the addition rule, right? So probability A union B is equal to probability A plus probability B minus probability A intersection B, right, guys? So you can immediately go with this formula. So probability of A is 0.42, probability of B is 0.37 minus probability A intersection B is 0.12. So guys, what's the answer? So when you add 0.42, 0.37 minus 0.12, the answer is 0.67, right? So that's the answer for part A. So moving on to part B, find the probability of A given B complement. So guys, for this, we already defined the formula. Do you recall? So we defined the formula in the previous section. So if it is probability A given B, the denominator, the given that probability comes to the denominator and the intersection of the two probabilities comes to the numerator. All right, so let's do that. So over here, the denominator is going to be probability B dash because that's the given that part. And on top, you should get probability A intersection B dash. Can you see, guys? So on the numerator, you should get A intersection B dash. So I think we will probably have to draw a little bit of a diagram here to see how A intersection B dash comes, right? So let's quickly draw. This is A and B. Probability of A is 0.42. Probability of B is 0.37. Probability A intersection B is 0.12. So I think, guys, you can easily get the two values here, right? So what are these two values? Let's get these two regions. This is simple A, B, C, and these are simple A. The reason I'm marking these A, B, C, D regions are because I can, talk about these particular regions without, just by mentioning their name. So region A is 0.42 minus 0.12, which is 0.3, right? Yeah, 0.3. And region C is 0.37 minus 0.12. Okay, so that's going to be 0. So we subtract 37 minus 12. It's going to be 0.25, right, guys? And also you can, since you have the regions A, B, C, you can easily get the region D as well. So region D is actually 1 minus A plus B plus C, or in other words, 1 minus A union B, isn't it? 1 minus A union B, 0.67. 1 minus 0.67 is 0.33. So you can find all these regions to make your life easier. All right, so we have the Venn diagram. All regions are found. Substitute the values. So what's A intersection B complement? A intersection B complement is which region? So the region belonging to A and the complement of B. I think by now, I really don't think I need to do this again and again, right? We know it's the region simple A, 0.3, right, guys? I think all of you are okay with that because we've done this so many times. I've shown you how to get this probability by using the regions so many times, right, in the previous video. So you have seen that. Probability of B dash is 1 minus probability of B, or 1 minus probability of B is 0.37. So guys, what's the answer here? 0.3 over 1 minus 0.37. So part B answer. All right, guys. So this is the answer, right? So you can type in the calc, get the answer. 0.476 will be the answer correct to previous step, or you can give the exact figure as 10 over 21. All right, so we'll move on to next part. Okay, so look at this. They say the event C has probability C equals 0.3. The events B and C are mutually exclusive and the events A and C are independent. Guys, over here, now they are talking about some independent events and some mutually exclusive events. So guys, I really wanted to first understand. I think there was a confusion in part A and B as because some of you might have assumed that, A and B are independent. So the thing is this, unless they tell you that the events are very specifically independent, you are not allowed to use it. Now over here, do not assume the independence result, okay, because I think some of you might have tried to get answers probability A into given B dash is probability A, so you can't do that over here unless they tell you that the events are independent. You can't just assume that. All right, so basically in part A and B you don't have to use any of those independent event rules, but in part C, I think you can see in the introduction this question they are telling you now that certain events are independent and certain events are mutually exclusive, so you can use those facts. So they say events B and C are mutually exclusive. What do you mean by events B and C are mutually exclusive? Mutually exclusive events are events that do not have any intersection, so they do not they don't have any common region. So basically if you take the B and C, if B and C are mutually exclusive, okay, so if events B and C are mutually exclusive, basically the event B and C should not intersect. So if you're trying to draw now, basically you'll have to include the set C into this Venn diagram. So when you're including the set C, you have to include it in such a way B and C will not meet. Okay. And events A and C are independent. Of course, independent events can, the circles can intersect, right? Mutually exclusive, the circles don't intersect at all. Mutually exclusive circles are apart from each other. But independent events, the circles can intersect, but however, there is a certain rule, right? Okay, so let's get into this. So they are saying find the probability of A intersection C. Guys, the probability of A intersection C can easily be found. Do you recall the equation for independent events? If two events are independent, what's the rule? Probability A intersection C is probability A times probability of C, right? Do you recall this rule? If two events are independent, they tell you they are independent. So you can use the fact because they tell you A and C are independent. You can use the fact. So probability A intersection C is probability A times probability of C. All right. So this is a rule that you have learned previously, right? 0.42 is the probability of A. Probability C is given, right? Probability of C is 0.3. So you can easily find this. What's the answer? All right, guys. So you come to this point, and then in part B, they say draw a Venn diagram to illustrate the events A, B, and C. So now you have to consider all three events into account. So basically, as I told you, events B and C are mutually exclusive, which means you must draw a circle C in such a way it does not at all touch B. So in that case, you can't, draw circle C like this, right? Because circle C and B, they're not supposed to meet. So one way to draw it is actually to draw the circle C in this manner. Can you guys see the way I drew it over here? So you can draw the circle C in such a way. So if you draw it like this, circle C, the green color one I drew over here, you can see circle C has no intersection with circle B. But definitely you have to draw in the way it intersects with circle A, right? Because the events are independent or even if they're dependent, make sure you draw for the other circle, you have to draw it in such a way so that it intersects, because they don't say A and C are mutually exclusive. They say they are independent. Okay, so make it draw it in a way that they meet. Okay, so this is basically how the diagram should look. So let's draw that. All right, guys. So you can see I have drawn the three circles. So A and B, this was the previous diagram. I have attached circle C. But when they ask you to draw the Venn diagram and to illustrate the events ABC, giving the probabilities for each region. So every single region, the probabilities must be marked over here. So guys, I gave new regions A, B, C, D, E, F. You don't really need to mark A, B, C, D, E, F. Okay, so I'm only marking this for the purpose of communicating with y'all. Okay, because I want to say that I'm talking about this region, and that's difficult to do when I have named the regions. I can easily communicate. Okay, so you don't have to mark A, B, C, D in your diagram. You can directly go ahead. Okay, so first thing first, let's try to get the information. The total probability of circle A is 0.42. I'll mark that at the top. The total probability of circle B is 0.37. And probability C, do we know? Yeah, the event C has probability 0.3, which means this is at the top here. All right, guys. And then I think we found some intersections. Can you see A intersection C is 0.126. So A intersection C is the intersection, this part over here, right? So this is 0.126. This is 0.126. And then what else do we know? We also know the place where circle A and B intersects, right? Can you see circle A and B intersection is 0.12. Guys, are you following me? So these intersections don't change. The A intersection B probability, A intersection C probabilities are going to be there. So those are the most important things you need. And then what you need to do here is, guys, let's do a subtraction and get the A, C, E, and F probability. So how do you get the A probability? 0.3 minus 0.126. How much is the answer? 0.3 minus 0.126. What's the value of region A? 0.174. And then you can also easily get the value of region C. So all these regions must be filled, because that's what they say, find the probabilities of all the regions. So all the regions must be found. How do you find the probability of region C? That's really easy. You know that the three regions B, C, D, the three regions add up to 0.42 because that's the total probability of A. So from 0.42, you should subtract 0.12 and 0.126. So 0.42 minus 0.12 minus 0.126 gives you the probability of C. What's the probability of region C? Okay, so that answer is 0.174, right, guys? So you can easily get it from the cal. And then the next answer, so this is D and E together. You can see circle B has a probability 0.37. I think we have already found it, right? Yeah, from the previous part. 0.37 minus 0.12. So that should be 0.25. That does not change, right? All right, but now I think the outside probability should change because we have drawn a new circle and taken a certain proportion out of it. So how do you get the probability of the outside region? So you will have to subtract the probability A, B, C, D, E. All these single probabilities should be subtracted from 1 in order to get the outside probability. So 0.174 plus 0.126 plus 0.174 plus 0.12 plus 0.25. You add all of them and subtract and deduct it from 1. Okay, and then you should get 0.156, right, guys? So that's quite a simple calculation, and you have now completed the Venn diagram. So this is the complete Venn diagram where you have marked every individual probability in each and every single region. So this is the complete Venn diagram. Okay. So they say part E, find the probability of A dash union C whole thing complement. Probability of A dash union C whole thing complement. All right, guys. So what we'll do here is, you know, what's the first thing to do here? Let's, so you can try some traditional ways, or you can, you know, I'm just going to try it with the regions, okay? Because we know regions and we know how to easily find probabilities using regions. That's what I'm going to do. This is gonna be first let's get A dash union C. Okay, first let's get A dash union C and then go into the complement of A dash union C later because we have to get the full complement of this, right? All right, so A dash union C. What is A dash? What are the regions belonging to A complement? A complement means all the regions outside of circle A. Guys, can you see? So this is circle A. This blue color one is circle A. What are the regions outside of circle A? To go to A complement, you have A, E, and F. Do you agree? A, E, and F belongs to A complement outside of circle A. Region A, E, F. And then next circle is C. So next we have to take the regions belonging to circle C. Circle C is this. Okay, so that is A and B. So what's happening when you take the union? So union means you take everyone into account, right? Okay, so union means you take everyone, all the regions come. So region A, you have A, B, E, and F, right, guys? A, B, E, F. This is what you have for A dash union C. But the thing is, you're supposed to get A dash union C complement. So you need the complement of this. Complement of this means we need to get the regions that don't belong here. So if you have A, B, E, F here, what are the regions that don't belong here? So what are the regions that we don't have here? A is here, B is here, we don't have C, and then we don't have D, we have E, F, right? So we have basically only C and D. So only C and D. Do you agree, guys? Okay, so I just had to get the probability of region C, that's 0.174 plus region D 0.12. What's the answer? 0. Yeah, so your answer is 0.294. All right, guys. So I hope this is clear with everyone. So these are just ways to get the probability. You can try to find this probability in different ways. So there are many other ways you could try as well by using 1 minus A dash union C. So you can try all these methods. Okay, that's perfectly fine. So I just hope that you all understood how to modify a given Venn diagram, add another circle, add another complete set into a given Venn diagram, and make the necessary changes. This is something that you definitely need to be able to do in your exam. Okay.